Out there, far beyond the edge of our solar system, something changed, and we didn't expect it. Voyager 1 didn't go silent, it didn't fail, and it didn't stop sending data. Instead, it started revealing something far more unsettling. The space around it, a region we once assumed to be mostly empty and predictable, isn't behaving the way our models said it should. The signals coming back are subtle, easy to overlook at first, but when scientists began studying them closely, a different picture started to form. Voyager isn't just drifting through empty space anymore. It's moving through an environment that we don't fully understand. And everything it's detecting is quietly challenging decades of assumptions about what exists beyond our solar system. To understand why this matters, you have to understand where Voyager actually is. In 2012, it crossed a boundary known as the heliopause, a point where the influence of the sun effectively ends. Inside that boundary, everything is shaped by the sun, its solar wind, its magnetic field, and its constant stream of charged particles. But beyond it, you enter interstellar space, a region that belongs not to our sun, but to the galaxy itself. For a long time, scientists believed that this space would be relatively quiet and simple, a thin and mostly uniform environment stretching between stars. But Voyager's data is telling a very different story. One of the first surprising discoveries came from something that scientists translated into sound. Voyager detected oscillations in the plasma around it, subtle vibrations in the charged particles that fill interstellar space. When these oscillations were converted into audio, they didn't resemble random noise. Instead, they formed a kind of consistent, almost steady hum. This was unexpected because interstellar space was assumed to be more chaotic and less structured. Instead, it appeared to have regions of density and organization that hadn't been predicted before. This alone suggested that the space between stars might be far more complex than we had imagined. As Voyager continued its journey, it began detecting something else, an increase in cosmic rays. These are high-energy particles that originate from violent events like supernova explosions, traveling across the galaxy at nearly the speed of light. Inside our solar system, we are partially protected from them by the sun's magnetic field, which acts like a shield. But beyond the heliopause, that protection disappears completely. Voyager is now fully exposed, and the levels of cosmic radiation it is detecting are higher than expected. This tells us that interstellar space isn't calm or passive. It is active, dynamic, and filled with energy that constantly interacts with anything moving through it. Then came one of the most puzzling observations. Scientists expected that once Voyager crossed into interstellar space, the direction of the magnetic field would change significantly. It should have marked a clear boundary between the sun's influence and the galaxy beyond. But that's not what happened. Instead, the magnetic field outside the heliopause appeared to be aligned almost exactly with the one inside it. This wasn't supposed to happen. It suggested that the boundary between our solar system and interstellar space is not as clean or defined as we once believed. Instead, it may be more like a transition zone, where the influence of the sun and the galaxy overlap in ways we don't yet fully understand. When you put all of these observations together, the plasma waves, the increased cosmic radiation, and the unexpected magnetic field alignment, a pattern begins to emerge. Voyager isn't just detecting isolated anomalies. It's revealing that interstellar space is more structured, more interconnected, and more complex than we predicted. The environment beyond our solar system isn't empty. It's a place where forces interact, where energy moves, and where the boundaries we once defined begin to blur. And that leads to a deeper question. If our understanding of interstellar space was incomplete, what else are we missing? Voyager is only one spacecraft, traveling in a single direction, yet even that limited perspective is enough to challenge what we thought we knew. It suggests that the galaxy itself may be far less predictable than we imagined, and that the space between stars holds more structure and activity than our current models can fully explain. Right now, Voyager 1 is still sending data back to Earth, still moving farther into this unknown region, and still providing insights that no other mission has been able to offer. But there is a limit to how long this will continue. Its power is slowly fading, and one day the signal will stop, not because the journey has ended, but because the connection has. And when that happens, we won't just lose a spacecraft. We'll lose our only direct link to the space between stars.